Hi there, welcome back to the channel and welcome to the second video in the restoration series of the Braun TS2. In this video, I'm still focused on the audio section, but it's going to end with something a little bit different. I'm going to show you just how long it takes to remove Bluetooth from a tube radio. In other words, to hide any signs of the sacrilege of adding Bluetooth to a tube radio. I'll get back to that in a second. But first of all, I go through the audio section, and strangely enough, a lot of the capacitors were really bad. In fact, just about all of them were pretty bad in the audio section, in the tone shaping section, and then a few rather strange surprises were waiting for me in the how the tone works. It's rather contrary to what I was used to, you know, normal treble, normal bass. Not quite the same here, but it's interesting nevertheless. And I wanted to see what the effect of that was. I'm going to do a sweep across the band, the audio band, and see what the effect of the tone is going to be. Now back to the sacrilege. There's been rather a heated exchange with someone who really attacked me because of the fact that I'm adding Bluetooth to a tube radio, and it's according to him, not something you do. My argument was, it's the way I want to do it. I do it the way I need it. And if you do want to reverse it, it's completely reversible. He didn't agree with me. So if he's still watching, because I did invite him to stop watching my videos if they offend him so much, I'm going to end this video with a connection and disconnection of all Bluetooth from this radio. So I time it. It's surprising what the result is, but if you want to know what it was, you're going to have to stick around and watch the video. Hope you enjoy it. Well, it looks pretty much the same, but believe me, a lot has happened since I last saw you, or since you last saw this radio. One of the things that hasn't happened is I haven't got the dial glass printed yet. The guys need some time. They've also suggested that instead of doing it on glass, they're going to do it on acrylic. They guarantee me it'll come out exactly the same. I'll wait and see. But in the meantime, I wanted to move on with this, and I wanted to get the entire audio stage completed, and I'm happy to say that's exactly what I've achieved. Let me show you what I've done. I had already checked the output power tube, so the audio output itself was working. It required the changing of the cathode bypass capacitor, which is this guy up here. And then I went back to the preamp stage with the volume pot and the two tone controls. Now this is slightly different in terms of tone controls, and I'll show you that when I show you the schematic. But these are the capacitors that were changed. There's one back there, one there, one there, one there, one there. These were all in the tone shaping circuit, and they were all pretty bad. This is something that surprised me a little bit. Mind you, they were the ones we expect to go bad, but I didn't expect them to be that bad because a lot of the other components are actually in very good shape. And then I had to move on to the volume pot itself. You see up here on the volume control, there's one, two, I think there's another one on this, two on this side, three, four capacitors, and two of them, I'll show you them on the schematic, I'll tell you which ones. Two of them are screened capacitors. Now those capacitors have a shield around the outside, which is metallic, and then that is connected to a ground point. I had to make them, and I think I did a video on how I did this. I'll link to that if I can find it. But that means that the entire tone shaping circuit is now done. So we should be able to just send a signal into the phono input and follow it all the way through. I also found something that was not quite the way it's supposed to be on the schematic, but I'll discuss that as I show you the schematic next. So this is what we've got so far. And as you can see on this right-hand side, you might have noticed I used a slightly darker shade of green to show you what I've done since the last video where I followed the power. Now, as I said, I'm focusing on the audio, and we'd already done this little section over here. So we have to move back. And the way to move back is to look at the input to the output tube and see where that comes from and what happens to the audio before it gets there. The other way to do it is to actually follow where the audio is going to come in. And that is over here. And we know it's over here because the important thing is the volume control. The volume control will show us where the audio comes from, what happens to it, before it gets there and after it gets there. So this is it. This is the volume control. And one side is connected to ground over here, which is as we expect. In fact, this thing is different to some of the other German radios in that there's no feedback circuit on the low end, meaning this end over here. So it goes straight to ground. And if we look at the top of the volume control, that's where the input signal would come from. And that comes from here. And as you can see, this 25 nanofarad capacitor is the one that blocks any DC in or out from the audio sections. And we get it going to this switch over here. This switch, this is B1, B2, B3. So it selects between that point and that point. And the one I'm interested in right now is this one over here, which is the phono. If it's switched that way, whatever's down here is going to go in there. And it looks pretty simple. Here's the phono socket. There's the ground. There's the phono in. Goes into there, gets selected, goes in there. And you're into the pot. Perfect. By the way, between this input here and this point here, there's a 220k resistor in the radio, which is not on the schematic. And there's another one down here. Now let's see what this is. This thing here goes straight to the same input over there. And you follow this down and you see this is your tape in. So the tape in is exactly the same as the phono in. This is that DIN socket at the back. So a signal coming in here will go up there. It goes through a 220k resistor as well, which is not shown in the schematic. And it goes to that point which switches through. And of course, if you want your tape in, you have to select TA, phono in, tape in. And that's the one that I'll be using to do all the testing for now. But then we've got another point down here, and it goes to the tape out. And that makes sense. If you look at this, you've got this point here, which is the radio. So this is phono or tape, and that there's radio, and pt2 switches between one or the other. When I say radio, it could be AM or FM, could be any of the AM bands or the FM. That's quite normal. So the signal from the radio, whatever you're listening to, comes down here, gets split or reduced by this 2 meg resistor and this 50k resistor, just a potential divider, and your signal goes to your tape out. So that's pretty simple there. This then goes to the magic eye, but we'll look at that later. And actually this tells us that there's probably DC on here because that's going to the magic eye. Okay, so that's another reason why we've got this DC blocking over here. Okay, now let's look at this section over here before the volume control takes the signal off to the preamp stage. This is a typical loudness function on most of these German radios. The potentiometer, instead of having just 1, 2, 3 points, has also got these two others. And what this does is it changes the tone as your volume goes down, as you lower your volume. I believe the term is psychological loudness. So when you drop your volume, your sound, the bass gets increased or gets pronounced, or the treble gets cut, depending on how you want to look at it. It's probably more accurate. And it allows the sound to sound richer at lower volumes than it would do if you had this huge, just this huge resistance between the top and where the wiper would be. I've explained this many, many times on previous radios. I believe I did talk about this in the Back to Basics, one of the Back to Basics videos. So go and check that out. But as you can see, this thing is quite complex in that it's got 2 tappings on the volume control there and there, and different frequencies get bled off to ground. It really is a bleeding to ground because there's your ground, your signal comes in, the capacitor will stop lower frequencies and allow higher frequencies to escape to ground. This is a different range of capacitor or different range of frequencies that'll bleed to ground. And here's another one that'll bleed to ground. So this whole section here is it's a selective bleeding to ground of high frequencies depending on where your volume control is. I think that's as clear as I can make it. If you've got the volume on high, it doesn't bleed many high frequencies to ground. If you've got it on very low, more and more high frequencies get bled to ground, and therefore your tone over here, the one that's going to go off to the preamp, becomes richer, becomes more bass heavy, bass rich, which is one of the real great characteristics of these tube radios. So we've got our signal here that's being tapped off. It goes through a blocking capacitor here. Now, this capacitor and this capacitor were shielded in that besides having these 2 legs, one leg and the other, there's another leg, and the other leg is actually wired to a shield around the capacitor, some kind of conductive material, could be just foil or something, and that then gets connected to ground to prevent noise from coming in or going off. Now, of course, you can't buy those capacitors anymore, but they're easy enough to make, and I've got a video on that. I'll link that, or I have linked that above, so you can go and see exactly how to make that. It's very, very simple, and it works very, very well. So our signal has left the volume control, and it's going off to the preamp stage. I've been meaning to do this for some time, and I finally decided to do it. What I've done is I've taken that volume control circuit, this one here, okay? I've started here at the input, and I've got the output over there. Okay, so I've reproduced these components, and what I've discovered or measured is that this particular point here is at 130k from ground. So that's 0, that's 130. This one's around 500. And then, of course, the final one is 1.4 meg. So what I've done is I've taken this circuit and put it into LT-Spice. And this is what I've got. And I've got a few more resistors here just to get a few more readings. But this is what I've got. This is the schematic. From here to here is the pot. Why have I got all these resistors? Well, I could probably find a way of simulating a pot, but I decided just to get a few fixed points. And these are the points I've chosen. From ground to this point here is 130k. That's that first tap off that I mentioned. And the second one, this one here, would be at 500k from ground. So it's 370k between that one and that one, okay? So 130 plus 370 comes to 500. And then the remainder is 900 to get to 1.4 meg. And I've divided that in two as well. Now I'm going to simulate this. I'm going to send a signal here that's going to start at 20 hertz to, I think I've set it to about 10 kilohertz. And let me show you what it looks like. So here's the start. We've got a flat line at 0 dB. Now if I take this point over here, which is just the signal coming in through a 25 nanofarad capacitor, this is what I get. And that is to be expected. This is a very short, this is a very small drop, 1.3 dB. And so if we take this 0 dB over here, the minus 3 dB point is, it lets everything through. It lets all the bass that you're ever going to want to go through, because 25 nanofarads is a high value for this, okay? Now, if I analyze this from the point of view of the volume setting, if I'm looking at that, that is the same thing as having my volume set to max, because I'm measuring there, right? So my maximum, my volume is on max. Now remember, this is just what is coming out of the pot going to the preamp. What happens if I set it to the 500k point? Okay, watch this. The scale has changed. This is the one where all the volume is going through. And look what's happened here. So we've got it at about a third of the way up. And the curve has changed quite dramatically, very dramatically. In fact, between 20 hertz and 1 kilohertz, we've got a difference of something like 16 dB. So what it's done is it's brought down the volume down here, but it's allowed more bass to come through. If you listen to this signal over here, you're going to have bass and treble more or less at the same levels, at the levels that you'd expect it to be at, right? If you bring it down to a third of the way, you've now got more bass. You see that? You've got much more bass than you would have. And when I say you got more bass, you've got less volume compared to that one, obviously. But you've got more bass compared to the higher frequencies. Now what happens if I click on that guy there? Now this, obviously the scale has shifted again, but look at this now. You've got an even bigger difference, a bigger curve, a bigger slope here. The drop between 20 hertz and 1 kilohertz is now something like, what does that come to? Something like minus 21 to minus 50. So you've got about 20, 25, 26 dB of difference over there. So your difference between your bass and your treble has increased dramatically. But let's do this again and do it in steps. And don't forget, every time I click here, the scale changes, right? So there's our baseline. There's our full volume. There's the volume if I set it between halfway between the 500K and the 1.4 meg, so at about almost 1 meg. That's it down there. You've got a big drop in volume, but you've got a curve that's being formed over here, and the difference now between your bass frequencies and your mids and trebles is something like for about 2 dB. Okay, not much. Now we go to that one. That's staying the same, about 2 dB, but now this one is at minus 8.5, going all the way down to minus 21. So you see the difference here is becoming quite more pronounced. If we go one step further, there's our purple curve. And again, you see a slightly more pronounced difference. One step further, and look at that. It's really starting to show. And finally, that one. Now, what happens between these two is that your signal is being tapped off here. When your signal is being tapped off here, it's right at that intersection of those bleed off stages. When you're halfway, you're sort of dividing the effect. So you get a quite uniform drop. There's not that much difference, actually. If you look at it in terms of the difference between here and there, what have we got? 12.87 dB. And this one, 14.6 dB. So not a big difference. But if you look at that one now, you've got a drop of 32 dB. So yeah, okay, I finally get to simulate the circuit, which I've wanted to do for some time. After all that messing about with the computer screen, I want to show you what this thing looks like on an oscilloscope. I'm going to feed in a signal, a normal sine wave. We'll see what that looks like. But I also want to show you the frequency response going from, say, 20 hertz to 15 kilohertz, maybe even 20 kilohertz. We'll try that. And I found a way that we can actually see that on a scope using my signal generator with a sweep function triggering one channel of the scope. So let us start. So what have we got here? I've got the signal going into the phono input. I've got TA selected, phono selected, and I'm going to put the volume up. And you can see it, I can hear it. I'm putting this on dummy load so I don't have to hear it. And there's our output. Now at the moment, my signal generator has got an amplitude of 100 millivolts, maximum volume, okay? Which means that it's not being affected by all those taps on the volume pot. And I want to see where it goes to. Let me reduce that. I want to see where it goes to, how high it goes to before it starts clipping. So I'm going to put that up to, say, 500 millivolts. That's what the signal amplitude is coming in. Now remember, there's still a resistor between it and there's a 220K resistor that I mentioned on the schematic. So it's being sort of attenuated a bit. Let me change the range again. Keep going. I think we're almost there. Yeah, hang on. That is, there it starts sort of bending at the top and the sine wave goes everywhere. See that? It sort of loses its shape. I mean, you could get away with that. That's 4 volts. That's already pretty distorted. I suppose if you want to call it undistorted, that'll probably be it there. That's about, actually it's about 2 volts. Again, I've said this before, I'm always a bit stunned by how these things work. They supposedly give you a very low power, but the sound quality is astounding. So I'm not going to argue. Now, at this point, I discovered something else, and that is that these, this is actually the treble, and that is the bass. Hohen and Tiefen, if I'm not mistaken. German speakers can correct me. So this works in reverse. And what it seems to be is that both of these are treble bleeds. It's like the way they get bass is to remove treble in a different range, which is a bit odd. So I'm going to do the following. I'm going to send a sweep signal from the signal generator, and the sweep is going to be, what I'm going to do is I'm going to put it down to 100 again, put this on max, and I know it doesn't clip. Is that a good range? Maybe 200? Yeah, let's leave it like that. 200 millivolts RMS, and I'm going to put a sweep on here. And the sweep is going to go from, let me show you, it's easier. We'll start the sweep at 20 hertz. We'll stop it at, let's make it 20 kilohertz. Let's do the 70 milliseconds again, because that's a, I'll show you on the scope in a second why. Make it a linear sweep. Yeah, we've still got 200 millivolts RMS. There's our sweep. Now, there's something else happening here. When it does a sweep, it sends a signal from the trigger out, the sync out, which will be a square wave with a period equal to the sweep time, which I have set to 70 milliseconds. So if we look at the scope now, my trigger signal is coming into channel 4, and the audio result is coming into channel 3. So on channel 4, what you should be seeing Did I make it hidden? Yeah, I made it hidden. Dummy. Right, there's our trigger signal. Now we've just got to get this right. See that? The time base is 5 milliseconds per division. This is 14 divisions. So the sweep time from the beginning to end is 70 milliseconds. Get it? If I made the time base 10 milliseconds, then I can get the same effect by making this 140 milliseconds. Okay? So that's what we're seeing on here. And what we're seeing on here, let me hide this trace. This one is being used as the trigger. So I can't get rid of it, but I can make it invisible. And now we're only seeing that guy, okay? Now, okay, that'll probably be the best way to do it. I can actually bring it down. You see, you're seeing the top and bottom. The frequency response, you should actually just cover the 1/2, okay? And there's one other thing you've got to take into consideration. This is not in dBs, this is in volts. Now remember, if you see volts, you'll see massive changes. With dB, it'll be a few dB, or could be a few dB. So what we're seeing here is the signal starts at 20 hertz, and it increases all the way to 20 kilohertz, and then it starts again. Okay? So what it's doing is it's telling us what amplitude those frequencies, the varying frequencies, are when they get through. And this is approximately, I think, yeah, that is linear. So this would be 7. Did I make it 20 kilohertz? Let me make it 14 kilohertz. So that's 14 kilohertz there. That's almost zero. That's almost 20 hertz. So it's almost DC. So what we're seeing here is we've got 1, there's the middle, 7, 8, 9, 10. At about 10 kilohertz, it sort of peaks up again. And we've got a dip in the middle. Now, this has all got to do with the tone shaping, with our tone controls. Let me show you something. I'm going to put this low, and you'll understand why in a second. I'm going to increase this, but I do want you to see what happens when I take it from a dummy load to speaker. Now, I might have to put the audio off because it is annoying. See that? It changes, and therefore that tells us that we can't really judge this frequency response on a dummy load. In fact, we can't even judge this with a dummy speaker, with a workshop speaker, because these systems are designed for a complete unit, including the type of speakers they've got, the cabinet they've got. The only way to accurately measure the frequency response is if you put this in a audio test chamber with precision microphones and measure the response that way. So I won't bother too much, but I do want to show you what the effect is of the tone shaping, okay? So there is the response we've got at the moment, which is actually a little bit strange, because watch this. This is supposed to be, in my mind, this was the treble. Now, if I change this, this is on minimum. Look what it does. It does something strange at the bottom, because this is actually the bass. And you're not seeing the effect, because the effect of the bass is probably up to about 300 hertz. So we won't see that. I'll change the sweep in a second. Now, if we play with this guy, this is on maximum left, so minimum. Now, if I do this, look at that. It almost cuts it completely. It reduces the treble as opposed to increasing the treble, which is really weird. Now that's bump you get right at the bottom. See that? Let me do this slowly, right? It's all the way to the left, and I'm starting to rotate it. It's a logarithmic pot because it actually works very fast. In fact, I think it might be a reverse log if I'm not mistaken. See that? Really, really strange. And believe it or not, when you make this, when you apply music to this thing, it doesn't have that drastic effect. It's really strange. I can't explain it. Let me change the sweep to, let's say, stop at 1 kilohertz. Okay. So now we're seeing there, that doesn't affect much the treble. Now we're seeing the domain of the bass control. Let's see what happens here. See that? Massive bass boost there. And this is bass cut, so you want more bass, you go that way. But again, it looks almost wrong when you do it on a system like this. And then when you put the sound on, you'll notice that it actually works. I want to show you next something that somebody argued with me recently on emails. They said it was sacrilege to put Bluetooth on here. In fact, they said that I was an absolute fake restorer for putting Bluetooth on these magnificent tube radios. Well, I've got a few things to say about that. 1, my radio, my rules. 2, you don't like it, don't watch it. 3, these things are absolutely reversible. And what I'm going to show you next is I'm going to connect it into the various points on here. And then when it's all working, I'll test it. It's going to be this Bluetooth that I built up in a recent video. I'm going to time myself removing it, and we'll see just how long it takes. And we'll also see just what signs of presence it will leave there. How's that, right? Anyway, I did tell the guy, you don't like it, don't watch it, so you probably won't see this anymore. But for those of you interested, I'm going to show you how long it takes to completely remove Bluetooth, the signs of Bluetooth from this radio, and the traces that it leaves behind. How's that? We'll put a stopwatch on it. The first thing you need to do is to decide where you're going to place it within the cabinet. And fortunately, this thing is quite big, so we've got quite a few choices. But when you look at it this way, I think the place is obvious. This thing's going to go right in there. It'll be out of the way, it'll be safe, and also it'll be able to receive the Bluetooth signals straight through the front panel. And it's going to then tell us how far we need to take this cable to the radio. So that means this thing is going to be somewhere here. And of course, we've got to decide where we're going to take it into the radio, because we want to connect this to the phono input and also to the heater supply and also to the signal that goes to the Magic Eye, which is right on the other end over there. And I don't want to go there. So what I've decided to do is I've decided to bring it to here where the phono socket is. I'll connect the phono to here, which is this wire here, the audio cable. And then I'm going to put the other 3 wires, so the heater supply and the Magic Eye signal, that's going to go through there, and then we'll see it on the underside. But I did make this cable a little bit too short, so I'm just going to lengthen it a bit more, because I figured out that if I want this to be up here, I need a little bit more length. I need another, 10, 12 centimeters. So that's the first thing I'm going to do. This radio's got a very convenient heater supply line, which comes across the top. It's that wire over there. And from each point that it needs to get to the tube, it solders down. It goes through a little ferrite to the heater supply. So we've got all these points over here that we can use. I'm going to use this one here, and it does mean that it's also isolated from that heater with the ferrite bead that they've got on each of the heater legs. So what I need is ground. Here's my heater wires, and I need ground, and I've got a ground right here, that one there. That is a nice strong point straight as this thing comes in. I'm going to solder the ground one to there, and I'm going to solder the supply one to there, and that'll give us our heater supply. So let me do that first. There we go, that's done. That's soldered there to ground, and the positive, or the 6.3, soldered to that point over there. And now we've just got to figure out what to do with this guy. One more quick look at the schematic. I promise you this is the last time on this video. I want to find out where the B plus comes to supply the Magic Eye. There's the Magic Eye down here, and we can see that if we follow this line up here, all the way there, all the way to there, that is where it gets switched on. It's B9, B8 and B9. So the B2 plus comes along here. When you deselect phono, it switches that on, okay? So let's look at B9. Where's B9 and B8? We want B9. And our B is here, it's on the phono, and it's the 2 last ones. So one of these is, that's probably 8, and that's 9. I think that's the one we need there. But we can obviously check that, and we'll do that right now. Okay, radio's on at the moment. I've got it on FM at the moment. So there is B8 and there's B9. If I measure that, whoops, you don't want this to slip, 239, 239. So our Magic Eye is getting a signal. Now if I go to phono, I've still got 239 there, and this one has nothing. Put on one of the radio stations. Let's see if that changes. Yep. So that's the guy we want. We want B8. Is that right? We want this guy that switches off when we have phono. That's it. And when we put radio, any radio, that comes on. So we want to solder that to this guy over here, not the last one, to the second to last one, so it'll be B8. And that's exactly what I'm going to do now after I switch it off. So this guy's going to come underneath here, through there, and it's just going to solder to that point over there. There we are. That is soldered to there. What do we still have to do? Well, we still have to solder the phono connection. And that just means soldering these two guys, which I've tinned correctly, note correctly, ground to ground, to the phono connection. And we're done. Just a matter of testing it now. I'll go to the royalty-free music library again. And there we go. The volume here is almost on max because then I control it from there. Sounds pretty good actually. We can see the Bluetooth signal blinking in there. Obviously this will be covered, you don't need to see that. Let's try the tone controls. This is the bass now, remember? Whoa, too much. Too little. There's a happy medium. And this is treble. If I put it all the way to the right, it's got the least amount of treble. And this is the most treble. So it sort of works in reverse. Or maybe I'm just not seeing it. The point is, it works. Now, I want you to watch that little light over there when I select any of the radio. Let's go for shortwave. It's gone off. Power's been cut by the relay. Back to phono. And you see the Bluetooth blinking again, and I heard the signature tone on the speakers. What's that? That's long wave. It goes off. And phono, it comes on again. See that? So this is working perfectly, and all I need to do is cover this up and I'll be putting it on the radio, but I want to show you how long it takes to get rid of any signs of this sacrilege from the radio. Let's switch it off and do that and time it. I'm going to set this timer and I'll be pushing stop and start so that we break while I move the camera around, okay? But as soon as I start, I'm going to set the timer and we'll see just how long it takes to remove the Bluetooth from this radio. Okay, first thing, we need to get rid of this guy and that guy. So I'm going to do this and I'm going to do this. This is why I left these longer than I needed, because I'll be playing with them later. That's out. It's gone. Just under 45 seconds. Not bad. Now let's be fair. I would still need to get the soldering iron out and remove the little stubs from the various solder points. So 1, 2, 3, 4, 5 solder stubs that I would remove. Give it a bit of fresh solder to make sure that the connection is intact. So let's give it another 3 minutes. So in less than 5 minutes, I'm being absolutely generous here. In less than 5 minutes, we have removed all traces, note, of Bluetooth being added to this radio. So that's the extent of the sacrilege. You can get rid of sacrileges on a tube radio in 5 minutes. I recognize that that probably doesn't occur in anything else, but on a tube radio, get rid of Bluetooth in 5 minutes. So that's my rant about the reasons why I have no qualms about adding Bluetooth to a tube radio. And let me go on just for a second, if you bear with me. I have a friend who's a real fine art restorer. She does old painting, she does church ceilings, she does all that stuff. And we've both, in conversation, have agreed this is not really restoration if you compare it to what she's doing, okay? She's making her art look exactly the same as it was when the painter moved away from the easel. That is not what I'm doing here. I mean, all you got to do is look at the capacitors. Those yellow caps look different. The fact that I try and keep some of them the same, like the filter caps, and I stuff them, that's just a choice. The point is, when I'm restoring a tube radio, I can't say that I'm restoring it aesthetically. I prefer to say that I'm restoring it functionally. And in fact, I'll go one step further, because somebody else argued that the function of this radio is not to reproduce Bluetooth music. So I will reclassify my restoration process. I'm not even restoring it functionally. I'm restoring it in terms of usefulness, because as far as I'm concerned, this radio, when it has Bluetooth in, will be used. If not daily, then every week someone will put it on, probably a teenage kid in the house, which is the only time they're going to go near one of these things, because this is granny's type of radio. They're not interested, but you give them Bluetooth and they find it cool. They find vintage cool. I hope that applies to 60-year-old men one of these days. But anyway, the point is, these things become incredibly useful and popular in a household, and that's the way they should be. They should not be just shelf pieces, because that's a real shame. That is not why I restore radios. So that's my rant, and I'm sticking to it. And once again, I do hope that those of you who are purists, I've got nothing against that, will forgive me my indulgence in making these things useful for me. So that's where I'm going to leave you for today. I'm going to get off my soapbox and thank you all for your company. Hope you've enjoyed that. And if you have, do click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Once again, thanks for watching. Bye for now. And most of all, stay safe.